He's known mainly for his work on fusion. In the fall of 2006, amid controversies surrounding his work on the collapse of the trade centers, he was relieved of his teaching duties and placed on paid leave from Brigham Young University. In 2006, he retired from teaching, and he misses teaching and is glad to be here today doing that again. He comes from Utah, where he has a lovely wife. At this point, he now has started the S&J Scientific Company, which is in Utah. So he's published in over 50 peer-reviewed journals, including Scientific American, Nature, which is the premier science journal in which he's been published 3 times, and the Physical Review Letters. So let's welcome Dr. Stephen Jones.
Thanks, Janet, so much. Thank you. Thank you. I appreciate that. Thank you very much. It's a great honor to be here in Sydney, Australia, and a great pleasure to be teaching again. I really do miss teaching. Today, I will approach this as a lecture to a worldwide university. Since I no longer have an active university position, I realize that I miss teaching very much, and so I realize also that as this is videotaped, that this will go out to a worldwide university. So I welcome you as students around the world, and I will try to treat this somewhat as a lecture that I would give, perhaps a last lecture, you know, in a series of other lectures. And today we'll be talking about World Trade Center destruction, the destruction on 9/11 that occurred at the World Trade Center, as everyone in the world, I think, is aware of that. We'll look at some behind-the-scenes events that not so many are aware of, that people tend to shy away from, but we'll confront this as good, inquisitive, critical thinking students, and we will seize the bull by the horns and see what really happened on 9/11. That's our goal. Now, there's so much to cover in this field. I will treat these 3 topics and throw in a few extras for you. But the fact is that in order to cover all of 9/11 research, now there's so many researchers, very good researchers and qualified around the world, that I have to assign some homework. And in fact, I hope many of you have already read some of these peer-reviewed papers. Otherwise, and let me put it more positively, as you read the peer-reviewed papers, it prepares you for understanding and sorting out the facts from the fiction. There's all sorts of fiction regarding 9/11, and there are facts as well. Now, you know, as we look at science, peer-reviewed papers are basically a final step in the process of research. Not a completely final step, because then other scientists can read the paper, see what you've done, attempt to repeat the experiment, for example, write a rebuttal paper. This is very common in science. And I welcome this, because then it gives us a chance to say, well, maybe I did something wrong. We'll check. And this is the case. I actually issue a challenge to scientists throughout the world to read these 3 peer-reviewed papers in established journals, and a 4th that I'll mention, and rebut what is written here. See? That's the challenge. Now, I will discuss some things then that are contained in these papers. And so if you haven't done your homework, please make note of these papers. You can go to the Journal of 9/11 Studies, which is listed here at the top, Journal of 9/11studies.com, all one word. And that way you can link to these 3 very important papers and the 4th. Now, let me just tantalize you a little bit, hopefully, from this 14 points paper. In this paper, I quote a letter from NIST, the National Institute of Standards and Technology, which is under the Department of Commerce in the United States. And NIST was charged by Congress to do a study, a detailed study of the collapse of the towers, the World Trade Center towers, as well as World Trade Center Building 7. And in the letter, in this paper, I quote from a letter from NIST, and I just want to quote that here. It's at the top of the screen. NIST wrote to me and my colleagues, "This letter is in response to your April 12, 2007 request for correction, which is a formal procedure saying, NIST, you made some errors. We need you to correct these. Answer us, please." They provided some answers, but then amongst those few answers, they admitted, "We are unable to provide a full explanation of the total collapse," referring to the World Trade Center towers. Now, you may not have heard that in the mainstream media. The fact is, NIST admits that they were unable to provide a full explanation of the collapse of these towers. This admission, after publishing some 10,000 pages on the subject, and then they admit they're unable to provide a full explanation. So please read the paper, and I'll talk about some of these weaknesses in the NIST argument as we go along. This is the fourth paper that I would ask you to read. 3 in established journals. This one is in the Journal of 9/11 Studies. I don't claim that it's an established journal, but it certainly was a peer-reviewed paper. This is the first paper that I wrote on the subject of 9/11. It's probably fair to say that this paper, as well as outspokenness on related subjects, cost me my career. And so please take half an hour and read the paper. Okay? All right. This is part of the homework assignment. Why indeed did the World Trade Center buildings completely collapse? Lots of pictures and background material. I will not be able to cover all that's in this paper or these other 3 papers today. In The Environmentalist, Kevin Ryan, James Gurley, and myself, Kevin is the first author, published a paper, Environmental Anomalies at the World Trade Center, Evidence for Energetic Materials. By this we mean pyrotechnic or explosive materials. At this time we had considerable evidence building, and this is in the Environmentalist, a very well-respected, peer-reviewed journal, and available, I'm sure, at all universities around the world. Should be available easily. Finally, in the Open Chemical Physics Journal, our latest paper, Professor Niels Harrit, Department of Chemistry, University of Copenhagen in Denmark. Active thermitic materials discovered in dust from the 9/11 World Trade Center catastrophe. Required reading. This will be on the exam, I assure you, the material from this. All right. All right. Now, I want to go back several years to 1986. One of my first papers in a peer-reviewed established journal, this in the Physical Review Letters, a premier journal in physics, in which I was talking about muon-catalyzed fusion. Here we made several claims. These were unexpected observations. The same sort of thing with World Trade Center 7 and the towers. That is, as we make observations, we find unexpected results and events and phenomena that then challenge our ability to explain and to account for. And this particular paper was challenged in other peer-reviewed publications, but our paper here, the major claims, were confirmed finally in other experiments. So we expect some challenge, and that's the way science proceeds. So far, the papers that I'm discussing today, the 3 papers published in peer-reviewed, established journals, have not been challenged. Now, I had a comment at lunch. Someone was saying, okay, I'm having trouble getting people to even look at the data. These are serious scientific types. And my recommendation to him was that he point out that there are these peer-reviewed journal articles. In fact, give him 1 or 2 of these to read. and ask him to respond, because that's the way science proceeds. It's basically a filter, this peer review process, so that you have all sorts of good ideas and nonsense hitting this peer review filter. What gets through and is published in established journals is considered to be serious and worth looking at. And you may even have to remind a scientist of that if the title of the paper has something to do with active thermitic materials. But this is a very serious paper. And it took months to study this, as well as to get it through the peer review process. Okay, so far no challenges yet, no peer-reviewed papers challenging any of these 3 papers. I'd like to mention also, by way of introduction, a paper in Nature, April 1989. This paper, along with a paper by Pons and Fleischmann, which was, their paper was quite well refuted, actually. You know, I allow research to continue. I look at it, of course. This particular paper claimed neutron production from a DD fusion process. You know, it's not totally unrelated to our topic today, because energy and the quest for oil, for example, is deeply related to, as we shall see, to this whole question of what happened on 9/11. I hope to present a convincing set of evidence for that statement. Anyway, so this is about energy. And we presented this paper in Nature. It went through the peer review process. It was a grueling process, as often peer review is. It was published in April 1989. And I presented results at the American Physical Society meeting that, I believe it was that same month. It was within a month of this publication. It turns out we were right in the sense that other experiments now have been performed and have confirmed our hypothesis at the time, which I've put in quotation marks there. Metals catalyze nuclear fusion, and some metals will enhance fusion more than others. This was really theoretically unexpected at the time. It was a result that we observed and published. It has now been confirmed in experiments in Japan and Europe. A quote here from Zersky et al. From the European Physics Journal, in which they point out that their experiments with accelerators can explain the neutron production rate observed by Jones et al. This is our paper in Nature. And this paper was published in 2004. So it took several years, that's 15 years, to be really established. Hopefully it won't take that long to get results established with respect to 9/11. But the process that I look at as a scientist is that we do experiments, we write a paper, we have colleagues check it, and then submit it to an established journal. They check it through their peer review system. It's anonymous, almost always. The peer review system is anonymous. That is, you don't know who the reviewers are. Sometimes you can guess by how mean they are or something. But then their paper is published. Then others can challenge that if they will. Otherwise, the results stand. And so far, our papers on 9/11 remain unchallenged in the peer-reviewed literature. So I will first talk now about the World Trade Center dust. How can we tell if it's dangerous? We do experiments, of course. And those experiments were done early on. And then some of these other topics you'll see as we address these. Let's look at this dust. We all saw the enormous dust clouds generated as the World Trade Center buildings were brought down one way or the other. The dust was tested by scientists immediately to determine the degree of danger. Greg Swayze of the United States Geological Survey wrote, "Tests revealed the dust to be extremely alkaline, a pH of 12.1. Some of it was as caustic as liquid drain cleaner." Now, you wouldn't want to drink liquid drain cleaner, to say the least. But you can imagine this dust, as it hits the moisture in your lungs and nose, it becomes this extremely caustic fluid. It was obvious that precautions had to be taken to protect the workers and people. So you see, this dust was deemed by scientists immediately through experiments to be extremely dangerous. It also contained asbestos and some other nasty stuff like mercury from all the fluorescent bulbs that shattered and contributed to the dust, you see. These results were sent to the Environmental Protection Agency, EPA, in the United States. However, the EPA issued 5 news releases within 10 days of the attacks, 9/11, 4 more by the end of 2001. All of these reassured the public about air quality. But nevertheless, even though they were reassured, respiratory ailments began to surface in hundreds, because you cannot deny the facts. This dust is extremely hazardous, and it was hurting people. Now, why would the EPA issue reassurances about the dust when it was, in fact, extremely dangerous? You might ask yourself that question. A BBC News report noted that the number of people with medical problems, primarily from the dust, has risen to at least 15,000. It is expected that more people will die prematurely than were killed on 9/11. So this is a very serious concern, this terrible dust. Now here's what happened. As you see down towards the middle of the slide, a report was issued by EPA Inspector General Nikki Tinsley. She studied what happened, and this came out in the summer of 2003. And here's what happened, reading now at the top. At the White House's direction, this is the Bush-Cheney administration, the EPA gave New Yorkers misleading assurances that there was no health risk from the debris-laden air after the World Trade Center collapse. According to this internal inquiry, she's doing her job. The White House convinced EPA to add reassuring statements and delete cautionary ones. Now, how would you feel reading this and you breathed this dust? You dutifully went back to work. As you remember, the Bush-Cheney administration encouraged people to do, particularly in the financial districts. Let's get back to work. And yet this dust was, in fact, exceedingly dangerous. Read a little more about this. This is from the Downtown Express newspaper as this report came out. This is from Jane in New York City, New York. It was much more important to open up Wall Street than it was to worry about our health, said former city councilperson Catherine Freed. We've known it was a cover-up since the beginning, Jane said. And so you have people aware, finally, of the government having lied to them. I mention this in part to help you understand that here is a clear example, irrefutable, I believe, of the government of the United States lying to its own people. Now, you might ask yourself, is it serious? Well, it's serious to the 15,000 who are impaired because of breathing this dust when they were told it was safe, and it was not. Not at all. Now, what happened to Nikki Tinsley, this Inspector General for the EPA, as she showed how the White House had covered up the truth? They sacked her. And now to lighten the mood just a little bit, I put in a cartoon that shows the nature of pseudoscience or bad science. So here's this ancient scientist. And in the first frame, he says, after years of relentless study, laborious research, innumerable calculations, I have hereby ascertained that, he's working on his peer-reviewed paper, or to be peer-reviewed, no two snowflakes, oops, here comes two snowflakes, and they look just alike. So what does he do? Destroys the evidence, and then he says, no two snowflakes are alike. This is considered to be not just a no-no in science, it is considered to be the worst offense you can make, I think, to destroy evidence. And in this case of the dust, what the administration, the Bush-Cheney administration did is not only did they destroy or hide the evidence about the danger of the dust, they falsified it. They turned it upside down and said, oh, it's safe, go back to work, you see. Now, as we look at this toxic dust incident, what does it tell us about the values? Truth. The scientists were outspoken, several of them, including this Greg Swayze, warning people about the true dangers of the dust despite what the government was saying. Caring for others was certainly absent on the part of the government, and the long-term effects, which that's one thing. It took a long time for these ailments to, well, for most people, it took a long time for the ailments to show up. Actually, for some, it was right away. By the way, these characteristics, these values, truth, caring for others, and considering long-term effects, I find in what's called the 9/11 truth community, as we seek the truth and we care for others and try to share. And think about the long-term effects of 9/11 and of ignoring 9/11. Now I want to shift to the next topic, the question of put options. Quoting from the Bloomberg News, trading in so-called put options, which rise in value when stock prices fall. Let's pause there. If you're not familiar with too much with a put option, a normal stock, when you buy it, you hope it will go up, right? And then you can sell it for a profit. With a put, the idea is that you're betting the stock will go down. If it goes down, you make money. See, it's just another way of investing in the stock market using put options. So they rise in value when the stocks fall. Now here's what happened. The two airlines involved in the 9/11 attacks, their stocks went down. This is United Airlines, UAL, and American Airlines. Their stocks went down dramatically. And what is reported here in Bloomberg News is that trading in these put options surged as much as 285 times the previous average value in the days before 9/11. About 6 days before 9/11, this trading started in United and American. An article by Don Radlauer, he notes that no similar trading in other airlines occurred on the Chicago Exchange in the days immediately preceding Black Tuesday. Now, doesn't that make you wonder, how did people know to buy put options, which would make money when the stock goes down, in these two airlines that were involved in the 9/11 attacks, and only those two airlines? Doesn't that raise your suspicion level just a bit? I hope it does. These people are making money on other people's deaths. It just boggles my mind. I hope you understand that we have values amongst us that are much higher than just making money, for heaven's sakes. BBC, 18th of September, so a week after the 9/11 event. American authorities are investigating unusually large numbers of shares in airlines, United and American. Insurance companies, specifically those which insured the World Trade Center, and arms manufacturers, they believe the sales were by people who knew about the impending disaster and were profiting from it. Can you imagine? Bloomberg News again. This would be the most extraordinary coincidence in the history of mankind if it was a coincidence. I hope you're not that gullible. 285 times surge in United and American, and it's just a coincidence. Come on, please. This could very well be insider trading at the worst, most horrific, most evil use you've ever seen in your entire life. He expresses it well. It's absolutely unprecedented. The amount was estimated by Andreas von Bülow at $15 billion in these trades. This problem, this very suspicious, unusual activity in the stock market was covered in a peer-reviewed paper, which I think has not been mentioned too much before. Professor Alan Peteshman, I've emailed to him, and he stands by his conclusions, of course. And I have not seen any challenge to his peer-reviewed paper. I'll read the last sentence. Consequently, the paper concludes that there is evidence of unusual option market activity, these put options, in the days leading up to September 11th that is consistent with investors trading on advanced knowledge of the attacks. I don't see how you can say otherwise. Now, this could not very well be ignored by the 9/11 Commission. They have to deal with this. It's in a peer-reviewed paper and in the media. So what did they say? Quoting now from page 499, a footnote. They sort of buried it deep in the book in a footnote, but they do talk about it. Here we go. Highly publicized allegations of insider trading in advance of 9/11 generally rest on reports of unusual pre-9/11 trading activity in companies whose stocks plummeted after the attacks, namely United and American. Some unusual trading did in fact occur. I'm glad they didn't try to deny it this time. It's so obvious. But hold on. Each trade proved to have an innocuous explanation. How could that be? With no conceivable ties to Al-Qaeda. So what's the problem? People are making a little money. It's not Al-Qaeda. It's innocuous. Can you see this, what they're doing? They have the blinders on so firmly that even though people are profiting from other people's deaths, thousands, it's innocuous because they're not tied to Al-Qaeda. Now, look, folks, what I'm trying to say here, students, is that it's not just Al-Qaeda, obviously. These put options were not made, they did that. They checked. Oh, it's not Al-Qaeda. Well, we won't worry about it. Come on. Who is it? Who is making money on other people's deaths? And that's my argument here as I've studied the events of 9/11 and the physics phenomena as well, as we'll discuss shortly, is that there's something else going on here, much more sinister and hidden, but besides Al-Qaeda. And the official conspiracy theory, it is a conspiracy theory, right? These 18 hijackers didn't act individually and separately. They conspired. That's a conspiracy theory. It's the official one from the United States government, the same ones who lied about the dust, okay, telling us that it's just Al-Qaeda. Don't look behind the curtain for anyone else. It's just Al-Qaeda. Don't look for the man behind the curtain. And as long as we just keep focused, it's only Al-Qaeda, then we can go fight them, preemptively in Afghanistan and Iraq and next, who knows, Iran. They'll come up with some excuse. I'm not trying to be facetious here. I'm just saying that it's incredible to me that the 9/11 Commission can look at these data and say it's innocuous if it's not Al-Qaeda. Incredible. There has to be some level of decency within us that cries out that this is unjust and unfair. And you don't have to be a scientist or a non-scientist to feel this way. If you care about people, you care about what happened on 9/11 and these 9/11 wars that have been excused on the basis of the official story that it's only Al-Qaeda. Now, foreknowledge. We have in the newspapers and media shown at the bottom of the slide, Der Spiegel, Die Zeit, BBC, and so on, warnings by over 11 countries, warning of impending attacks, warning U.S. officials. Okay? And then, in particular, we have Russian President Vladimir Putin. Just 4 days after the attacks, listen to what he says. I ordered my intelligence to warn President Bush in the strongest terms, this would be before 9/11, that 25 terrorists were getting ready to attack the U.S., including important government buildings like the Pentagon. Jane's Intelligence Digest, another respected outlet. It is rather strange. The U.S. media seems to be ignoring what may be the most explosive story since the 11 September attacks, this foreknowledge that they were coming. Bush, of course, denied any foreknowledge. Now, here's another element that speaks of foreknowledge. You see, this fellow in an interview 2 days after the attacks to Dan Rather. His name is Tom Kenny. He said, very matter-of-factly, we're currently one of the first teams that was deployed to support the city of New York in this disaster. We arrived on late Monday night, that would be the 10th of September, and went right into action Tuesday morning. They were already there in Manhattan with their equipment, hundreds of emergency workers. Now, this is confirmed by Mayor Giuliani in his testimony to the 9/11 Commission, which testimony was not included in the final 9/11 Commission report. He said, the reason Pier 92, not too far from the World Trade Center, was selected as a command center was because on the next day, September 12th, Pier 92 was going to have a drill, an exercise from the federal government, the state, from FEMA, and so on. They were getting ready for a drill for a biochemical attack. So that was going to be the place they were going to have the drill. The equipment was already there. Now, folks, that's efficiency. You think about, right, the day before, they're already hundreds with the equipment needed for 9/11 in the right place. It's just a remarkable. Maybe they probably were rewarded for their great efficiency, but to me, it raises a red flag of suspicion again, that there was foreknowledge there. You think about what happened at Katrina, the hurricane that hit New Orleans. Was FEMA Johnny on the spot? No, it was days. It just dragged out until they finally got there. Here, they were there the day before. I'm sorry, I'm very suspicious about this, and I would like to find out who ordered the FEMA exercise. As word about this and knowledge about this has gone around the United States, cities that are expecting a FEMA exercise have actually turned FEMA down. They say, we don't want your exercise. Why don't you take it to, I don't know, New York or someplace, you know? Why is that? It's like, yeah, we're starting to wise up a little bit here. Next question, why were there no air defenses on 9/11? Associated Press report noted the scrambling of fighter aircraft at the first sign of trouble, such as a hijacking or even a commercial plane going significantly off course, is a routine phenomenon. In the year before 9/11, fighters were scrambled 67 times. This is not an unusual event. A Boston Globe, a NORAD spokesman says its fighters routinely intercept aircraft. When planes are intercepted, they typically are handled with a graduated response. They don't just go up and shoot down a commercial plane because it's off course or even hijacked. They try to get the plane to land safely. Okay, this is not. There's this supposition that if you go up, these fighters are just going to shoot the plane. No, but these let's look at them. Let me come back here. These flights, the American and United flights that were off course. These are the three planes that actually collided with buildings on 9/11. You notice I've assembled the data here so that you can see when the planes were taken over. That means they're off course. And for instance, American Airlines 11 was taken over at 8:20. It crashed at 8:46. You see, so there's 26 minutes. Actually, that's plenty of time to respond. United Airlines 175, 8:42 was taken over. It crashed at 9:03. The main one I want to call your attention to here is American Airlines 77, taken over and off course at 8:46. Did not hit the Pentagon until 9:38. That's over 50 minutes where it's off course, and there were no air defenses to protect the lives of the people on the plane as well as in the Pentagon. Now, let's look at that. Here's Secretary Mineta, one of the chief whistleblowers of what really happened on 9/11. I hope you've got your critical thinking hat on, students, as we read the testimony of Norman Mineta, who was at the time the Secretary of Transportation in the Bush-Cheney administration. Here's an honest man, a Democrat, I might say, who was chosen to be Secretary of Transportation. And the situation is this. Because he's the Secretary of Transportation, he was called into this underground command center, which is below the White House. Vice President Cheney was already there in command. President Bush, you remember, was in Florida reading about goats to the children. That's another story. Suspicious, I think, that he was not whisked away after the second tower was hit. He sat there reading about goats for another 15, 20 minutes. Why didn't the Secret Service take him out of there? He was endangering these students by being present. We were under attack. He sat there. But that is another issue. Let's come back to Secretary Mineta in the command center under the White House. During the time that the airplane was coming into the Pentagon, he later confirmed this is the case. This is the plane that was coming into the Pentagon, and they are tracking it. People there tracking it. There was a young man who would come in and say to the Vice President, Cheney, the plane is 50 miles out, plenty of time to scramble jets and intercept and try to get that plane to land safely. Plenty of time. Then the plane is 30 miles out. Now we're getting down to the last chance. When it got down to the plane is 10 miles out, the young man also said to the Vice President, now, here's a young man that has some courage, right? He's challenging Dick Cheney to do something, right? I'd like to know who this young man is. He should testify about what happened and these orders. Because nothing was done. So these were obviously not orders to shoot the plane down because it wasn't shot down. It wasn't even met in the normal interception protocol. Mr. Vice President, do the orders still stand? And the Vice President turned around and whipped his neck around and said, of course the orders still stand. Have you heard anything to the contrary? Approximately 2.5 minutes later, over 180 lives were snuffed out. Nothing was done, people. Now, I raised this issue with others in about May, June of 2006, and I called for redress under the Constitution for impeachment of Dick Cheney. I felt I had the right to do that as a United States citizen, that he should have a fair trial. That's what impeachment means. I think I'll continue that story just a little bit. Right soon after that, I was speaking as an American citizen, not as a professor at Brigham Young University. But university officials approached me soon after that and said, please don't talk about Cheney. And so I didn't for a while. But in September, which would be about, June, July, about 3 months after I had talked about Cheney and requested impeachment, I was put on administrative leave. Do you know that I accepted early retirement? There's some pressure there. I retired in January of '07. In April of '07, 3 months later, Dick Cheney was given an honorary doctorate degree at Brigham Young University for public service. And I'll talk a little more. So I'm thinking, wait a minute, this is, whoa. There's a little, I'm getting to be a little bit skeptical, But I just wanted to bring that in here because it is relevant to this question of what happened, of course, at the Pentagon. There was no warning either. Here's April Gallup. She was in the Pentagon when it was hit on 9/11. She was crippled. She's crippled today because of the event there in the Pentagon. It's unusual that her baby was with her. I've heard her speak. She said that what happened was she was coming in to work at the Pentagon, her job, and she called in. She said, I have my baby, I need to drop it off, so-and-so. And they said, don't bother, just bring the baby in. So she did. And she said there was no warning whatsoever. Now we know from Mineta that they were tracking the plane. There's plenty of time at 50 miles out to warn the people to get out of the Pentagon. So, this influences your life as well as mine, and I think it's important, and hers, very dramatically. She said that she was in the Pentagon, this tremendous collision. She blacked out, passed out from that. And when she came to, there was rubble all around. You can imagine her disorientation. And she couldn't find her baby. And so she reached over. She's a praying woman, and she reached over and found, as she looked around, she couldn't see it, but she reached over a wall and found the baby holder, lifted it up, and got out, was able to get out of there. But she now wants to know, of course, why there was no warning. She's speaking out about this and has a lawsuit, as I understand, trying to get information. Why was there no warning, Mr. Cheney? Why did you not do something to intercept this jet coming in? There's plenty of time. Why did you not listen to this young man who conscientiously asked why nothing was being done? Okay, now physics. Everybody take a deep breath so that we now talk about the nice cut and dried, but very interesting. I had a physics friend of mine, Dr. Campbell, who said to me as I reviewed some of these facts that we're learning about 9/11, he said, scientifically it's actually very exciting to see these puzzle pieces come together and make sense, and it all fits, and it looks like explosives. He admitted that. But he said, but I'm very sad for my country. World Trade Center 7 on the afternoon of 9/11 of 01, and collapsed then 7 hours after the towers had fallen. In the photograph in the lower right, you see Building 7, viewed from the rubble of the World Trade Center area, and looking across. This would be the side that would be hit by debris from the World Trade Center. It's there's so much smoke in the area, it's hard to see much detail, but I don't see any huge gap. Of course, the Building 7 stood for 7 hours after the collapse of the towers. So obviously it was not fatally damaged, it seems. 24 steel beam core columns, 57 perimeter columns, a very large building discussed by Richard Gage. So on the left you see World Trade Center 7 coming down. On the right, a controlled demolition using explosives. They compare remarkably. Both are straight down. I mean, how do you get fires to cause a 47-story building to come straight down onto its footprint? This was, of course, discussed at some length by my friend Richard Gage. The 9/11 Commission report failed to even mention the collapse of World Trade Center 7, so it must be important. They neglected Minetta's testimony as well. The FEMA report said, our best hypothesis has only a low probability of occurrence. Of course, we agree with that. And we quoted them saying this in our 14 points paper that I alluded to earlier. So now we have the official NIST report, NIST, the lab, the federal lab under the Department of Commerce in the U.S., charged with explaining the collapse of the towers and Building 7. Here's some important background. NIST says in their report, other than initiating the fires in World Trade Center 7, the damage from the debris from World Trade Center 1, that's the closest tower, had little effect on initiating the collapse of World Trade Center 7. Agreed. So there's some things, that we agree with them on, actually. As they study this, they say, look, it's not due to the debris. And then how about the diesel fuel? There's diesel fuel stored because there are a huge electrical generator there in the building. In Popular Mechanics article in 2005, they cited this as a probable contributing factor, a major factor in the collapse of Building 7. So, from Popular Mechanics, investigators believe the fire was fed by tanks of diesel fuel. And the New York Times article also said the same thing. But in the August 2008 report last year, this notion is also thrown out. However, NIST writes, fuel oil fires did not play a role in the collapse of World Trade Center 7. As they studied this, they ruled that out. So it's not due to debris from the tower across the street. It's not due to oil, diesel fuel for the generators. So here's what they blame. They blame it on fire. The challenge was to determine if a fire-induced floor system failure could occur in World Trade Center 7 under an ordinary building contents fire. Again, we see an example of the blinders being on. They're not trying, it should, I think, read, the challenge is to explain the collapse, the rapid and complete and symmetrical collapse of World Trade Center 7 on 9/11. But instead, their challenge is to see if they can get fire-induced floor system failure, if that could explain it. Okay. Ah, dear. So how do they proceed? They used computer modeling. I might say they admit in the report they did not look at any steel samples from World Trade Center 7. And what they did then is they use a computer model. It's a black box. Now, I would like to know if they would be willing to release this model, but so far they've been unwilling to. There's a few things in this model that I think are physically questionable. So see what you think, students. Quoting from the report, the steel was assumed in the FDS, this is their model, to be thermally thin. Thus, no thermal conductivity was used. Let's see what that means. It means, okay, so you have you had a straight pin and you heat one end of it, like to get a sliver out. I do that when I have a sliver. I heat one end. Well, pretty soon the end where I'm holding the pin gets very hot. And this is because of thermal conductivity, which means the heat is transported along the steel. Now, a pin is stainless steel, typically, and these beams are steel. But the thermal conductivity is not zero. I've done the experiment with the pin. I know it's not zero. But in the model, they turn it to zero. You see? Now, that helps it to work, of course. But even if you're NIST, you can't throw out the laws of physics. I'm sorry. You know, it just is mind-boggling that they would do this trick. Furthermore, they write in their report, it appeared likely the critical damage state, where this thing started to collapse, occurred between 3.5 and 4 hours. Now, burning office materials, here's a photo inside one of the World Trade Center buildings, typical type office. You know, how do you get these office materials to burn near the critical column, which they claim was affected, for 3.5 to 4 hours, particularly when NIST themselves published earlier data that shows how total heat release rate goes up. You see, it reaches a peak around, what is that, somewhere around 700 seconds, 12 minutes or something. You've burned fires. You've done the experiment. You can assemble all the paper and toner that you want, chairs, tables, you know. These things tend to burn out in half an hour. And you see that rate of heat release tapering off quite rapidly. But no, they want not just half an hour or 50 minutes, they want 3.5 to 4 hours of burning near the critical column. What is there, someone in there pushing all the paper around this critical column, you know, to keep it fed for 3.5 hours? I'm sorry, it just boggles my mind. And yet, that's what they say. Plus they turn the heat conductivity to zero. Well, sure, if you burn a fire under a critical column for 3.5 hours, this office material, and turn the heat transport conductivity to zero, yeah, I can imagine some effects will happen, but it's not physical. You can, like I say here, your computer model will allow you to do any crazy thing, but nature will not. You know, it will not. So we would like to see the model released. And we will plug in realistic values. We'll give it it's well known, it's measured, you know, the heat conductivity for steel, we'll plug that in. It's an easy parameter to fix in their model. And we'll see how long it takes. I don't think it'll ever collapse, though, under that condition. It took them 3.5 hours with the heat conductivity off. The heart of science, students, is independent verification. I hope you know, we talk about this repeatedly as scientists. It has to be that other scientists can test what you're claiming, and they can publish papers that challenge you, and then You say, well, do this experiment and you'll see what we mean, and so on. But here, in this case, they're not doing experiments. They didn't even look at the steel from Building 7. They're doing a computer model, which they won't let us look at and adjust the parameters to be physically accurate. There's no independent checking possible. This is the very definition of pseudoscience, bad science, where they make claims and you can't check them. That is bad science. I hope you understand how frustrated I am with NIST. But we already know, again, a little humor to maybe lighten the... We already know who did it, don't we? So here's what they might pursue. From what we can gather, it appears a giant red arrow pushed World Trade Center down. I mean, you know, it's just good as their other model, and it doesn't require all this fancy, you know, turning the heat conductivity to 0 and all that. See, okay, you get the idea. All right. Now, the acceleration of the building, Building 7, as it came down. You can see from photographs, this from the, actually from the video, frames that at 1 second interval, you can see that the motion of the roof line, okay, it drops a little here and it drops here. I don't care when you start, students, for this. We're talking about acceleration now. Okay, so it's the change, the delta in the motion that counts. It drops a little, and then it drops more, then it drops more, and more. That is accelerated motion, not constant motion. If it's constant, it would drop the same amount, the same distance each second, right? You can see, I hope from this, from these data, that the building is accelerating in its fall. Now, listen to this, please.
This next question comes from Dr. Stephen Jones. NIST discusses the fall time for WTC-7 on page 40 of the summary report, where it's stated, assuming that the descent speed was approximately constant. However, observations by others of the descent speed show that the building is accelerating rather than being at constant speed. So the question is, why did NIST assume that the descent speed was approximately constant?
In the summer of 2008, when NIST came out with their preliminary report on Building 7, we were allowed to ask them questions by email, not in person. We've tried to sit down with them in person. They have declined to meet with me and other scientists in person. But they had this press conference, as you see in this room, where they were fielding questions sent to them by email. So I pointed out in their report, you see it right here in yellow, assuming that the descent speed was approximately constant. This is for World Trade Center 7. Well, you know, this is a very obvious error, okay? It's a junior high school student type of error to assume that the descent is constant when anyone can look at the data as they're supposed to do, they're charged to do by Congress. You can see that it's accelerating in its descent. And so I sent an email in, and I actually asked 3 questions. This was one of them. And in response to this, by the way, one of the others was, how about this explosive material, this red chips I'll talk about soon. Did you look for explosive residues in the dust? And they basically said, we're not going to look for explosive residues, period. So it's very sad. That's, again, unscientific not to even look. But here's what they came up with in response to my question, and David Chandler asked them a very similar question. We asked them without talking to each other first. We asked NIST to explain why they would use, why they didn't consider the actual acceleration of World Trade Center 7. So here, and now this is looking at the roof line, and you can see this is now in the final NIST report, where they do agree and they admit that this looking at the velocity of the roof line as a function of time over 2.25 seconds, it's a straight line, very close to that. It fits very well to a straight line. And then they actually do the determination of the slope. A physics student could easily take these data, look at the delta V sub y over delta t, and you'll get the acceleration. It's linear on this plot. and you get the acceleration. Here's what NIST wrote in their final report. The slope of the velocity curve is approximately constant between 1.75 and 4 seconds. A good straight line fit to the points in this range allowed estimation of the constant downward acceleration during this time interval. This acceleration, here's the punchline, was 32.2 feet per second squared, 9.81 meters per second squared, equivalent to the acceleration of gravity g. Folks, that's the same as if I took a steel ball and dropped it. Nothing in the way. Okay? That's free fall, and they admit that. This free fall drop continued for approximately 8 stories, 32 meters, 105 feet. That means that this roof was falling for some 32 meters with nothing slowing it down. I'm going to borrow from Frank Legg's paper a minute, this nice little illustration. This is for one of the towers, but the same thing applies at Building 7. If you have a block of floors, including the roof, falling onto columns and concrete, you know, hundreds of thousands of tons of mass, and then this one falling just freely, right? Nothing, somehow we've moved stuff out of the way. We'll talk about that, but you have to, it's not just the support columns, it's also the mass. The mass alone will slow down so that you cannot accelerate at g, which is the acceleration due to gravity. You understand? Students, rest? Okay. So let me ask you, which of these two roofs, the one on the left or the one on the right, will fall more slowly? This is not a trick question. The one on the left will fall more slowly. And why is that? Okay, I hear several answers, and I'll help you. Inertia, well, yes, conservation. Something in the way is the easiest way to put it. It boils down to conservation momentum. When a moving mass hits another mass, it slows down. It's conservation of momentum. And the third law will get you the same answer. Newton's third law. There's an upward force applied to something that hits this object with a downward force. There's also an upward force. So obviously, to get free fall, somehow you must have moved hundreds of thousands of tons of material out of the way. Now, fires will burn up paper and desks and so on. Will they burn up concrete? No, not just unlikely. No, the answer is easy. How about steel? Will they vaporize steel? No. So how do you, let's think just for a minute, how do we move thousands of tons of concrete and steel out of the way, or at least get it falling at the same time so that the roof is unimpeded, you see? How do we do that? Explosive. No, it's not magic. No. It's explosives, right? That's one way to do it. And indeed, if you look at controlled demolition where explosives are used, so you cut columns below the roof line, the roof indeed falls at close to acceleration due to gravity, g, just as World Trade Center 7. How do you get the mass out of the way? Now, NIST does not answer. We basically pushed them to include this plot because we challenged them, David Chandler and I, and they did it to their credit, but then you'd say, well, they would have to explain it, right? Or explain the collapse of the buildings, but they didn't. They just put a little statement in there, and they said that this result is consistent with the results, that's where I start quoting, consistent with the results of the global collapse analysis, that means their computer model, discussed in Chapter 12. That's it. It's a sham. I hope you understand that as a scientist, I'm offended by this type of covering things up. I mean, we challenged them. They admitted free fall for Building 7. Free fall for some 32 meters, over 100 feet. And then you're waiting for them to say, well, fires won't do this. But instead they just say, oh, it's consistent with our computer model, which we won't let you have, which you can't test. You can't see if it's consistent or not. You just have to trust us. You see? Like when we say the dust is safe, please just trust us. No harm will come. Please. You know, as a scientist, I just am appalled. So here's again, we contrast students, the scientific method with the political method. In the scientific method, we gather facts, and we then draw our conclusions from the facts, as on the left. In the political method, we start with a conclusion, And then we find what facts will support that conclusion, and we ignore all others, or we simply say, oh, it's consistent with our, our theory that fire can explain it, and Al-Qaeda is solely responsible. By the way, you know that no plane hit Building 7, don't you? Al-Qaeda did not even hit Building 7, and they ruled out, NIST ruled out, as they checked, that the debris from the falling towers did not cause a fatal incident at Building 7 either. So they're stuck with fire, which indeed was caused by the towers, they say. But gosh, the way it fell down is not consistent, no, with fire. This is free fall. Plus the fact that in Building 7, Professor Barnett et al. At Worcester Polytechnic Institute noted that the steel was severely eroded. High temperature corrosion and sulfidation, which again Richard Gage talked about that. Do office material fires do this to steel beams? The answer is no. I mean, please do the experiment. Show me wrong. I beg of you. Show me how you can get a steel beam to look like this. Swiss cheese in appearance, burning paper and desk and so on. Kerosene would be the jet fuel in the towers. There's also steel like this found in the rubble of the towers and studied by these scientists at WPI. Now, did NIST follow up on these data? It's in the FEMA report and was published also in a peer-reviewed journal. The answer is no. NIST did not even look at any steel from World Trade Center 7. Not even these pieces that were collected. Again, they ignored the data. They asked us to trust their computer model, that somehow the free fall for over 2 seconds is innocuous, if I can use the term. Don't worry about it. Well, excuse me. There's something very strange going on. I am not just going to believe you that this is okay. It's just appalling. But hopefully they will someday say, well, like they admitted, we can't explain the total collapse of the towers. Well, perhaps they'll admit that with regard to Building 7 as well. But to ignore published data is, again, an offense in science. Okay, students, you're better than that. Let's see. I might say that this effect of holes in steel I was able to achieve quite easily using thermate, which is sulfur added to ordinary thermite. Thermite you can buy on eBay. Sulfur is not hard to come by. You mix them together and you ignite it. I use a sparkler to ignite this typically. And you see the effect is, and I've looked at this with a scanning electron microscope as well. You see the sulfur penetrating the steel very quickly, and it forms a eutectic and it melts its way through. This is not even super thermite, which we'll talk about later. Just ordinary thermite with sulfur added. The steel is cut through, melted, and it has this Swiss cheese appearance. We're able to duplicate that. The WPI scientists also found sulfur in the steel in these samples. Where does it come from? You see, well, we have an experiment that can replicate. That's not a proof yet. To prove it, we would need to get a sample of this steel. We requested, as my colleague at BYU, Dr. Ferrer, talked to Professor Barnett at WPI and requested a sample of the steel, a scientific courtesy. He was refused. They will not. Now, somebody must have power to get these guys to let us look at their computer model, right? And we'll plug in the actual heat transport value for steel and realistic values for fire and so on. And also to get a sample of this steel. That's what we want. We're looking for data. We're not just trying to, be contentious. We want the facts. We have a right, I think, to ask these questions. In the past, asking questions has been commended, not condemned. Now, about the towers. We'll go through this kind of quickly. Richard Gage has a great article on that. I want to show you, you see here in the upper right, you have a stove burning wood. I have a wood-burning stove. And sometimes I'll put paper in there. So it's much like an office fire, I suppose. Office materials, typical in office, wood, paper. You could even put kerosene in there. I have a kerosene burning stove. It's also made out of iron or steel. You know, I don't expect that stove to deform and melt or collapse. It's just not going to do it. I've done the experiment many times. My kerosene stove also is quite happy to burn kerosene. You know, a jet fuel would be fine. It's a type of kerosene. I don't see a problem. Furthermore, you look at the connections on these columns. They're connected together. Well, you can see it in the picture on the right. That means that if you have a bonfire under one, go ahead, pile up all the desks and chairs and paper under one of those columns. And you start that fire off, and it lasts maybe a half hour or something. But that heat is wicked away. Again, it's this heat transport, you see. And so you have to take that into account. Except in a computer model, of course. You can get away with murder, actually, if you think about it. But okay, back to the official model now presented by Besant in a published paper. How to get a complete tower collapse. Their argument in this paper is that where the planes went in and there are fires, then somehow there's this weakness, rather simultaneous, and this upper block of floors acts as a tamper to push down. So it stays fairly intact as a tamper. Makes some sense, right? But wait a minute. How about Newton's third law, which says that if the upper block exerts a force on the lower block of floors, the lower block exerts an equal force, students, on the upper block. Equal. That arrow is not shown. It's not considered in this paper. It's there. You cannot overcome the laws of physics. Now, this is, again, a freshman error in physics, Newtonian physics, which I taught for over 21 years, to ignore the third law reaction force. But let's look at the data. Maybe somehow this upper block, as it moves, I don't know, exerts. Let's see what happens to the upper block from the data. This from the North Tower. And on the right, you see in slow motion, the upper block. Is it just wiping out the lower block? You can see the area where they meet. No, the upper block itself is being disintegrated. Did you see that? Let's look at it again, please. You can see the antenna poking up there. The antenna went through the whole ride of this thing. But you see, there's a force equal and opposite, up and down, and the upper block, which, by the way, has thinner columns. That's the way it was built. The columns get, the core columns get smaller, thinner as you go up. Furthermore, the fire would have weakened the upper columns, and indeed that's what you see. It's the upper columns that are destroyed. So then what is left, where's this block, this tamper that's supposed to wipe out the lower floors? Sorry, it ain't there, you know. I mean, look at the data. You know, it just bothers me that they have this nice model on the left, but it's inconsistent with observation. It's also inconsistent with Newton's laws. Here's another photo showing later as one of the towers has collapsed. You can see the zone of destruction. It's quite clear, isn't it? You can see where right through here. But where's the tamper? Where's this block of floors? Well, indeed, there's smoke coming up there. It's gone. On both towers, you see this effect. That upper block of floors is gone by the time you get halfway down of the buildings, approximately. It's gone. There is no tamper. And it doesn't wait till you get to the ground for the upper block to be destroyed. It's already destroyed. It isn't there. It's just amazing to me that they missed that. So the official story is full of holes, just like the steel found. You see, it's just full of holes. By the way, the towers also came down at near free fall speeds. No stacked up floors. Here's an actual photograph then following the collapse. Where are the stacked up floors if there's some pancaking going on? Like the Popular Mechanics article said, they're not there. On the right we have pancaking that can occur, but it didn't occur at the World Trade Center. There is no stacking of floors. Furthermore, the core columns are gone. Those core columns provided a lot of the support in these towers, and they are gone. That suggests again to me use of explosives. Now, let's see. As I started writing about this, and here's one of these papers that I asked you to read as homework, I received an email from a fellow who identified himself as a contractor with Homeland Security contacts. As soon as this article was out on the internet, he wrote to me. I'm going to quote from his email. "The publication of this article can be stopped, and I have the contacts to make this happen. You need to give this very serious consideration. This is an issue that is more important than any individual career." I think he was talking about my career. "As painful as it may seem now, perhaps it may be less painful than could occur after publication." That almost sounds like a threat. I don't know. "I have learned to appreciate the value of silence, even in the case of superior data and information." He could not refute my arguments, and so he said, "Shut up anyway." "I have learned to appreciate the value of silence." Now, this paper was formally published in a book by Professor Scott and Professor Griffin in August of, so there's several things happening, but anyway, August of 2006. In September 6th, I was put on administrative leave. I think this was probably part of it. And that was pretty much the end of my teaching career. Here I am teaching to a worldwide university, so thank you. Okay, thank you. NIST has found no evidence, this is quoting NIST, NIST has found no evidence of a blast or controlled demolition event. They made that statement, and then we wondered, because we're getting just a little bit skeptical, you see, we're thinking like scientists now. Wait, did they even look for explosives or explosive residues when they make this statement? Turns out they did not. So an investigative reporter, the reference is at the bottom, her name is Jennifer Abel, called up the NIST spokesman, his name is Humenn. She asked, what about the letter where NIST said it didn't look for evidence of explosives? See, they didn't even look. They admitted that finally in a letter. Humenn, who's listed as the spokesperson, right, because there was no evidence of that. Huh? Shh, go away. Abel, Jennifer, but how can you know there's no evidence if you don't look for it first? Good girl. That's it. You know, investigative reporting. Let's find the answer. Humenn, if you're looking for something that isn't there, you're wasting your time. Now, am I missing something here? I mean, this is offensive to my intelligence. How can you know in advance? You see, this could just keep going on circularly forever, but yeah. Okay, more information you can find at the Journal of 9/11 Studies, and here's some of the authors, as well as, of course, in these peer-reviewed established publications. Now, red and gray chips, a lot of fun stuff to talk about, but it's scientifically fun. In terms of what it means to society, well, that's up to us. It's an adventure to be in this with you worldwide addressing these issues. An adventure to me. So in June of '07, I observed many of these red-gray chips, as you see pictured here, in a sample of dust from the World Trade Center. We finally obtained 4 independently collected samples, and the chain of custody is well established with witnesses, in some cases with videotape of the collector explaining how he or she collected the dust. By the way, we know that USGS has dust samples from the World Trade Center. We've requested dust, and they say they just don't have enough. All 4 samples, this is a check we did, had the same active thermitic material, this red material, and it has been seen independently now by Mark Basile working in Massachusetts. Here's the electron microscope. Higher magnification using an electron microscope. We go in, you see the red layer on top. This is in the paper, so I'm going to go through this fast because you can read it in the active thermitic material paper. This is also from the paper. We see aluminum, oxygen, silicon, iron, carbon, prominent, no zinc. Primer paint, we check this, the primer paint. This is a knee-jerk reaction of the debunkers. Oh, it's just primer paint from the, painted onto the steel. It's just primer paint. Primer paint has lots of zinc. But we've gone a step further now. This is a new result that I want to show you. And that is there's actually a monument before 9/11 that contains actual steel from the World Trade Center 7. The fellow who put the monument together, welded it, he went out, he's now a 9/11 truther, and he went out and scraped off some of the primer paint from this World Trade Center 7 steel. Now we're going to compare with this red material. And the result, drum roll, is that they, thank you, on the left is the red material, the thermitic material. On the right is the primer paint. So are they the same or not? Well, in the primer paint you see a lot of elements. Iron is Fe, CO is cobalt, chromium, calcium, potassium, sulfur, silicon, aluminum, magnesium, and zinc prominently. Here's zinc over here too. It's going off the page. See a little better there. With this method, you excite the atoms and they release X-rays, and then you can identify the elements. The differences, I hope you can see, are distinct. The right is the primer paint, and the upper one is, 2 plots upper, is the red material, you see. So the red material shows no zinc. Right away you see that. That was the critical factor. We knew there would be zinc in the primer paint. There is no zinc in the red material, and indeed we do see zinc prominently in the primer paint. Magnesium is also seen along with, let's see, chromium, prominent chromium peak, as you expect from the composition of the primer paint. They're not the same. We also had a reaction from a debunker who said it's kaolinite. If you'd done a little checking, the USGS data shows this kaolinite, sure enough, it has aluminum, oxygen, and silicon, but no iron. And so it's just not the same. Furthermore, the behavior, here's an independent sample. The behavior when we ignite this stuff, comparing and when we treat it with a paint solvent, these are entirely different behaviors between the primer paint and the red chips. So here's, for example, soaking one of these red chips. It swells up, but it's still hard. When I soaked the primer paint in MEK, which is a solvent, methyl ethyl ketone, the paint became very limp. You can do this experiment. See, that's the beauty of science. It doesn't matter whether you're a 9/11 truther, so to speak, like myself, I seek the truth, or if you're a debunker, or why is it the debunkers don't do experiments? This is what I'd like to know. You know, you can do the experiment. It doesn't matter what your biases are. That's science, right? And when you do the experiment, then you publish. And somebody who wants to challenge you, he might be an atheist from, I don't know. It doesn't matter. You do the experiment, you get the same result. You see, that's the beauty of science. And then you find out facts that way. It's not like, oh, there's a big debate about this because who says this and who says... No, it doesn't matter. It's experiments and peer-reviewed papers, you see? That's how we proceed in science to get at the truth. Here's an X-ray diffraction pattern of a red chip. We're just starting into these studies now in earnest. And we hope to learn more with this independent technique. I want to point something out. As we look at high magnification, this is 50,000 power amplification in the electron microscope. We see, okay, let me point out to you these in the middle, if I can get there, these platelets, that's where the aluminum is held. These dots, you see the dots here? These faceted dots, that's where the iron is held. And then this stuff out here looks kind of gray. That's the organic. There's a lot of organic material. Now, the uniformity of these plate-like structures and the narrowness of them, these are remarkable. I have no idea how to make these things. And by the way, the aluminum we can separate from the silicon using MEK, so it's a very interesting material. The iron oxide, these ultrafine faceted grains, plus the organic matrix. This is not building stuff that just falls down and makes this wonderful nanothermite. I've heard that argument. I think, have you read the paper? Do you know how complex this is? You see, this takes some considerable knowledge, chemistry. In fact, we have a couple of chemists on our scientific team, and we have not been able to make this stuff. We don't even know how to do these. See, aluminum oxidizes very quickly. Somehow the silicon layer has passivated the aluminum. That means it makes it insensitive to the oxygen in the air, so that in this matrix it is preserved so that, 8 years after the event, this stuff still blows up when we cause it to react. You see, we've got the flowing material, and we've tried to stabilize the image for you so you can see this molten orange glowing material. There goes off the white wisp, which is, we think, then aluminum oxide. There's an important thing to understand here, and that is thermite, ordinary thermite, which you can buy on eBay, is incendiary. It burns, well, you say slowly, even though it's over in a flash. It's not explosive. It melts through stuff like steel. Ultrafine grain nanothermite, now it's called, is an explosive, or it can be made. It can be tailored, actually, and explosive. This, below you see a photo, lower right, from Lawrence Livermore Laboratory, which BBC asked if they could show this photo. It's a published paper. Lawrence Livermore Labs refused to allow BBC to show this publicly. Well, here I am. It's shown publicly. Please sue me. I need the to get the word out. That'll help. But it's so funny. This remarkable structure on the left is from, again, Livermore Labs, showing, again, this intimate mixing of iron oxide and aluminum in a sol gel framework. It's remarkable stuff, this nanothermite. And here are the analyses before and after ignition. Top is before. You see the composition. After, you see the aluminum is almost all gone. It has gone off into the air, aluminum oxide, as this reacts. What you're left with is iron, reduced iron. Now, see, before the oxygen peak is very large compared to the iron peak. Afterwards, the oxygen peak is small, and we were able to determine that the iron has been reduced. That is, the oxygen has transferred from the iron to the aluminum. Don't worry, that won't be on the test. But you still have to read the papers, okay? And where does the aluminum come from in these spheres in the dust, the bottom one you see? That's an unusual mix, iron, silicon, aluminum in a sphere. Some of them, the aluminum goes off more, but some of them, it's trapped or whatever, and the aluminum's there. What an unusual mix. Where does that come from, if not from this thermite or nanothermite? Quoting from Livermore scientists, they published a fair amount. So you see, let's see what they say about this. By introducing a fuel metal, a quick pop quiz. Oh, the answer's there. Too bad. I was going to quiz you. What is the fuel, such as aluminum, into the metal oxide, silicon oxide matrix? Okay, what's the metal oxide that we observed? Iron oxide, great, in these red chips, right? The silicon oxide is a matrix in which they're holding this fuel plus oxidizer. Energetic materials based on the thermite reactions can be fabricated. Now, organic additives, what's all this carbon doing in there? Can cause the generation of gas. That's what it's for. Upon ignition of the material, so you expect gas to be generated, resulting in a composite material that can perform pressure volume work. In other words, as it explodes, you get this hot gas. That's the trick used with C4 in a shape charge to produce this hot gas and molten metal that squirts through and cuts very quickly through steel. That's the trick. See, when I first saw this stuff, I could not understand what it was, because there's silicon, which is not needed, I thought, in thermite, and carbon. What's that for? Well, now I know what the silicon's part of the structure in the sol gel method of formation, and the carbon, the organic, you see, which has carbon, is used to generate gas. It all makes sense now. Now we have to do a comparison as good scientists. These scientists previously have published what happens when nanothermite is ignited. That's the red curve. When we ignite an actual red-gray chip from the World Trade Center dust, we get the blue curve. This is done in a differential scanning calorimeter. Yes, that will be on the quiz. And you see the narrowness of the peak tells you how rapidly, it gives you a good indication of how rapidly the reaction occurs. The height of the peak, or the integrated area, rather, tells you the amount of energy that's released in the reaction. what we found is that, and also the temperature at which the material ignites tells you quite a lot about its nature as well. Now, let me just show you one thing. I'll come back. There's a lot of data here. You probably have to read the paper to really understand it. This is in a paper published in 2004. And again, these are the boys at Livermore Lab. And on the right, we have nanothermite, a very narrow peak at about, I'm saying around 550 centigrade it goes off. The broader peak with ordinary thermite on the left goes off somewhere around 900, 1,000 centigrade, higher temperature. So by going to finer material in the nanothermite, the temperature goes down for ignition and the peak gets narrower. That's what we see with this amazing red material found in the World Trade Center dust. The blue curve, it's very narrow. It goes off rapidly. My friend Dr. Farrer says, yes, it blows up, you know, when he's done a number of these tests. And then the temperature is actually lower than what the Livermore boys did when they did their nanothermite. So that's, you know, it's a very interesting material. Read the paper for more detail on that. Here we go. First time this has ever been shown publicly. This is a red chip at very slow motion going off, very slow motion. These data were acquired by Mark Basil in Massachusetts using, I don't know exactly how he did it, but camera through a microscope and then he hooked the frames together to produce this moving picture. So the red chip, you see the red there, gray on top, it swells, it turns black, gives off a gas, and then it flashes, boom. Now if this were confined, that gas might react instead of just going off. That's an experiment I'd like to see, but one more time. And you'll see the red-gray chip very clearly. It's being heated on a stainless steel strip, gas given off, flash goes through very rapidly. Again, this is at ultra-slow motion. In the paper in which we discuss these red-gray chips, you'll find a reference to this AMTIAC quarterly journal. This is kind of exciting. Okay, figure 1 talks about the applications for this. It's called nanocomposite. Nanothermite is an example of it. These guys, Livermore, you know, thermobaric warheads, and then down at the bottom, a shaped charge. Can you see that? Let's see if I can use the pointer. So you see this is hollow here. Here's the material like C4, conventional explosive, in a shape such that when it explodes, you get a blast of gas, and then typically there's a copper liner also there, so that you get molten metal blasting out to cut through steel. That's how shaped charges work. See the shape there? It's kind of a cone, or if you linearize that, it becomes this wedge that forms the shaped charge to cut through steel. That's how buildings are demolished. Now notice what they're saying about the fuse right here on the end. See, they're pointing to that. The fuse or initiator, they're recommending a nanocomposite or nano intermetallic, of which a prime example is discussed in this article, which is a Department of Defense article, U.S., is nanothermite, nanocomposite as the fuse or initiator. In my opinion, this is the more likely context in which nanothermite was used in the World Trade Center buildings. Obviously, to find out for sure, we would have to either find unignited, well, we have the unignited nanothermite, but I mean unignited shape charge, which is unlikely. All that's been hauled off and melted, you know, all that steel. Or find someone who knows, you know, ask the questions, the tough questions, and get them subpoenaed. So here's the picture I'm suggesting now. Is my best thought of how nanothermite was used in the World Trade Center. It was used in these shape charges. In the top center, you see a shape charge, conventional, being applied to a steel beam. Isn't that amazing, this line? It must be about a centimeter, a couple centimeters wide, and then across the beam. Electrically set off, and that cuts through that huge steel beam. See? It's remarkable. Just remarkable. On the left, lower left, you see an example from the World Trade Center, which is quite interesting to me. But of course, that steel is no doubt melted That's what they did with over 99.7% of the World Trade Center steel. It was melted. It was sent to Asia, melted, destroying the evidence. We have the dust. We can learn a lot from the dust. But I'm suggesting that the nanothermite would appear then as a fuse or initiator. Now, why would you use nanothermite? Here, this is from Los Alamos, another national laboratory in the United States. I've worked at the lab as a postdoc for years. What they are talking about here is superthermite matches. So you have the nanothermite, also called superthermite, in these silvery globules with two wires, you see. You simply send a current through the nanothermite and it sets it off. Applications, according to Los Alamos, include triggering explosives for demolition. I'm not making this up, students. This is straight out of the publication, 2003, which you can find from Los Alamos National Lab. Why would you want to do that? First of all, you can touch this off electrically, this stuff, this nanothermite. Secondly, the superthermite matches are safer to use because they resist friction, impact, and heat, thereby minimizing accidental ignition. That's why you would want to use this. If you're worried about things going off prematurely, here's your solution. Ha! Plane hits building. We don't want too much to go off. Oh, superthermite matches. Aha. So then I got thinking, you see, why don't I try putting a voltage across this, one of these red chips from the building? I wish I had that on video, but I was acting alone. I've lost my position at the university, but I was acting alone with a car battery and these two sharp probes and a 12-volt battery, you see. And I touched one of the, I'll get it on video here, and I've recommended it to Mark Basil. He's set up better in Massachusetts. But he was skeptical at first as I talked to him, but he's convinced now that there's this explosive pyrotechnic material in the World Trade Center dust. So you touch the two probes, apply the 12 volts. I was holding it by hand, the two probes on the red chip, and it just went and of course I backed up very quickly, and I decided in the future, this is just a little chip about, less than a millimeter square, it's tiny, and I will have to have some remote way to do this. I figured out a way to do it. Another thing, by the way, I sent chips by U.S. mail to a post office box in the Midwest to a scientist. When it got there, and this was on an inner envelope and an outer envelope in a plastic vial that was closed tight. Two little chips. When it got there, the scientist opened his post office box, and as he checked, there was a slit in the outer envelope. There was a slit in the inner envelope that lined up. The vial, as he removed it, the chips were absent. U.S. mail. I feel like we have, Big Brother watching a little bit. Now, I sent, in that case, I told them, okay, the chips are coming. By email, I was communicating. More recently, I've sent chips quietly to Europe and an independent lab in the United States, and they did both arrive. I just didn't tell them I was sending them. And then they arrived, and they say, well, what's this? And, of course, then I could tell them. Here's again from Los Alamos about these superthermite electric matches, showing them going off. By the way, a colleague, I just got to tell you, a colleague asked Los Alamos, can you give us a sample of this superthermite match? You have photos of it. You have papers on it. What I wanted to do is take one apart and look inside and compare it with the World Trade Center red material, you see. Los Alamos, not only did they decline to send it to us, they said, well, we really don't have any of these. So I don't know. I see photos, and it looks like they exist. Maybe they were just faked. I don't know. But how could they set one off without having one? This is. I'm getting to be real skeptical. I'm sorry. We'll carry on. Oh, to make this stuff. This is just to get at the aluminum. The nanoscale aluminum requires sophisticated equipment. This is not caused by a building just falling down and magically. Aluminum is in platelets with silicon passivated and the iron oxide in uniform granules embedded uniformly mixed and embedded in an organic matrix. No, where does all the organic come from, by the way, if you have a building falling down? No, it's just crazy, that idea. I just am, again, appalled. There's some scientist who said that, and do you understand what you're saying? I mean, look at the complexity of making this stuff. So where could it be made in 2001? That's a key question. It turns out there are not many labs that have the capability to make this nanothermite, especially back in 2001. Conclusion, who made the stuff? Why has NIST refused to look for explosive residues in the World Trade Center dust? Also, USGS would not answer my questions about that. Okay, here's something I want to emphasize, students. We can learn a lot from physics and experiments, but how they were used, exactly who did this and how they were used. I keep getting that question. You must understand that observing this red-gray material doesn't tell me. There's no fingerprint on this little stuff. We need subpoena power. We need an investigation, perhaps, I think, at an international level. Some government, this was suggested by Bray Antcliffe, did I pronounce it more or less right? And his colleague, both of them lawyers, I hope I'm getting that more or less straight, Bray, that this would be something where, okay, a nation such as Australia, Japan, that lost citizens in the 9/11 event could ask questions of the U.S. government, request, demand samples of the steel, of the dust from official sources, right? USGS, we want that dust to look at for ourselves. We want some of that steel that WPI has. We want the computer model that NIST did. We will have our own scientist test. We want to know what killed our citizens on 9/11. The U.S. Congress is rather obviously not going to, I'm sorry to say, proceed on this. Maybe we can get the door to open if we pull it instead of push it. This is what happened to steel. It went into a lot of it, some of it went into this USS New York, this huge warship. You might have seen that in the news the last several days. Who sacked Mineta? It was Cheney. Did you know that? As his testimony came out, he was asked to retire or something, but he was sacked by Cheney. O'Neill, let me just say, Paul O'Neill, the Secretary of Treasury, he challenged Cheney on wanting to go into war with Iraq, which was announced in January as Cheney and Bush took office. He opposed Cheney when Cheney said deficits don't matter. Have you seen the U.S. deficit lately? It's going like that. The deficit, I mean, it's gone from 5.8 trillion, I checked, when Bush Cheney took office. It was about double that when they left, and then now it's up to close to 12.5 trillion. I mean, it's hard to keep up. The deficit is just going crazy. P.S. Don't sell your coal for U.S. dollars. Just a thought. Just a thought. Okay. Demand gold for your coal. Okay, just a thought. He was fired by Dick Cheney.
And what happened at President Bush's very first National Security Council meeting is one of O'Neill's most startling revelations.
From the very beginning, there was a conviction that Saddam Hussein was a bad person and that he needed to go.
He says that going after Saddam Hussein was topic A 10 days after the inauguration, 8 months before September 11th.
From the very first instance, it was about Iraq. It was about what we can do to change this regime.
Now, everybody else thought that grew out of 9/11.
No.
But this book says it was day one of this administration.
Day one, these things were laid and sealed.
As Treasury Secretary, O'Neill was a permanent member of the National Security Council. He says in the book he was surprised at the meeting that questions such as why Saddam and why now were never asked. It's all about finding a way to do it. That was the tone of it. The president saying, go find me a way to do this.
For me, the notion of preemption, that the U.S. has the unilateral right to do whatever we decide to do, is a really huge leap.
You're giving me the impression that you're just going to be stunned if they attack you for this book. And they're going to say, I predict, you know, it's sour grapes. He's getting back because he was fired.
I will be really disappointed if they react that way, because I think they'll be hard put.
But are you prepared for it?
Well, I don't think I need to be, because I can't imagine that I'm going to be attacked for telling the truth. Why would I be attacked for telling the truth?
So now we look at this question of Secretary of Treasury in 2001, as the Bush-Cheney administration took office. He was the Secretary of the Treasury, Paul O'Neill. And he reports, as we see in this video, that from the very first instance, it was about Iraq, quoting O'Neill, the president saying, go, find me a way to do this, to going after, getting into attacking Iraq. Now, O'Neill challenged this idea of attacking Iraq, and specifically he challenged the shift to preemptive war, which was promoted by Dick Cheney and others. When Dick Cheney said deficits don't matter, a famous statement, Paul O'Neill opposed that as the Secretary of Treasury. He thought that was not wise policy. As he opposed these policies by Cheney and Bush, he was fired by Dick Cheney in 2001. I think this has some relevance as to what happened to me, as we shall see. I am often asked, what happened at your university? I'd like to answer that briefly. I'll start with a quotation of Dick Cheney that he made at the Institute of Petroleum in London before the invasion of Iraq. And he said, rather candidly, I thought, by 2010, we will need on the order of an additional 50 million barrels a day, barrels of oil. So where is the oil going to come from? The Middle East, with 2/3 of the world's oil and the lowest cost, is still where the prize ultimately lies. Seems to be the way these guys think, as somebody else's oil is their great prize. Here's Cheney given the honorary doctorate degree. You see, I was pushed into early retirement in January of 2007. Now, in April of that same year, just 3 months later, Dick Cheney was awarded an honorary doctoral degree by BYU, which is a startling coincidence, if indeed it is a coincidence. I'd like to point out, as you look at this photograph of Dick Cheney getting the honorary doctoral degree for public service, that on the front row sits one of the trustees of Brigham Young University, and he has his head down and he is not applauding. Neither is his wife, who's sitting next to him. And I think that's rather symbolic of a number of us at BYU who weren't particularly pleased with this situation at the commencement in April of 2007. Now, going back to September of 2006, when I was put on administrative leave at BYU, we have these quotations from the BYU spokesperson, Carrie Jenkins. She was making it clear what was going on, what happened. She said, quote, this is from the Daily Herald, a publication in Provo, Utah, which is where Brigham Young University is located. She said, Jones was placed on administrative leave for publishing a theory that explosives were involved in the tower's collapse through channels university officials deemed inappropriate. BYU spokesperson Carrie Jenkins said, the university doesn't have an opinion regarding the theory, she said. Now, I found that very interesting. They made a point of that. Now, it's not really clear to me why they found the venues for publication that I chose to be inappropriate. One of these was the Utah Academy of Arts and Sciences, which I spoke in April 2006, and which was subsequently published. The abstract for this presentation was published in the Utah Academy of Arts and Sciences publication later, their journal. So I don't really know why they found the venues inappropriate, but they made it very clear, and this is the point I want to emphasize, that they were not denigrating my theory regarding 9/11 events. Because the BYU spokesperson said, quote, "The university doesn't have an opinion regarding the theory," unquote. Now, BYU also made it clear during these months in late 2006 that they were under considerable pressure from various sources regarding my 9/11 research, and this was reported on in the newspapers in Utah at the time. It was to their credit that BYU admitted that they were under pressure. Later press releases in January of 2007 stated that Dick Cheney's office had contacted BYU, and this resulted in Cheney's invitation to BYU to attend commencement just 3 months after my early retirement. So I think there might be more than just coincidence there. BYU also, to its credit, allowed 2 on-campus demonstrations against the policies of Vice President Cheney. These took place in April 2007, and I participated in both of them. This is, I believe, unprecedented at BYU to have 2 demonstrations against the policies of a politician. And any demonstrations on BYU campus are exceedingly rare. I can't remember any. I was at BYU for over 21 years. I can't remember any until these 2 on-campus demonstrations against the policies of Mr. Cheney. Of course, obviously, these were outside of the commencement exercise and before the commencement exercise. Now, behind the scenes, BYU encouraged me to continue 9/11 research after I was placed on leave. I was pleased by that, of course, and I was in particular allowed to use BYU's state-of-the-art electron microscopes freely. And the result of this research using the electron microscopes was that we discovered iron-aluminum-rich microspheres in the World Trade Center dust in January of 2007. And then in June of that year, we discovered this red nanothermitic material in the World Trade Center dust. Both of these, of course, were after my early retirement, but because I was allowed to use the state-of-the-art facilities at BYU, Dr. Jeffrey Ferrer, who's the director of the Transmission Electron Microscopy Lab at BYU, was allowed to work with me, and his help was crucial in this research. So based on that research at BYU, a team of scientists wrote the paper, which is now published in the Open Chemical Physics Journal. It's entitled Active Thermitic Material Discovered in Dust from the 9/11 World Trade Center Catastrophe, published in April of 2009. And I hope you will read it if you haven't done so. I want to point out that BYU reviewed this paper before it was published and found it to represent sound science, and they approved it for publication. This was, therefore, in essence, a peer review of this research, and conducted by myself and this team of scientists, international team. Now, I had requested in writing a review of my 9/11 research, requested that of BYU just after I was placed on administrative leave. That review was not granted at the time, but the review of this paper, Active Thermitic Material Discovered in the World Trade Center Dust, this review of theirs finally satisfied my request, and I'm happy to say that BYU approved publication. They also approved of listing Dr. Ferrer on that paper as second author, and Daniel Farnsworth, also of the BYU Department of Physics and Astronomy, was listed on that paper as it was published in the Open Chemical Physics Journal. Their affiliation with the BYU Department of Physics was listed in the paper with approval of BYU. BYU has also allowed me to have a shared office on campus after I was placed on leave. They allowed me to own my own office computer. It's a very nice computer with all the 9/11 information on it. So it could be said that they were quietly supportive. There are a lot of white hats at BYU. I won't talk about the black hats possibly here at this time. But the point is this. About the same time as this paper was peer-reviewed and published, I was given the honor of being named to Emeritus Professor of Physics at BYU. And in view of these contributions to 9/11 research, my fellow researcher and friend Kevin Ryan said, "Hooray for BYU." Professor Niels Herret of the University of Copenhagen followed with this comment, "Stephen, I am glad that you can see beyond your own and ours annoyance and point to the positive aspects of BYU's handling of their situation. Let me hasten to join Kevin and cheer for BYU loud and clear." Continuing from Professor Herret, "We have to acknowledge the political space they live and operate in, and BYU deserves the credits you point out. One senses a high level of decency at BYU. Kind of the same thing I feel in the mainstream press these days. The young journalists try to squeeze some information in and take the discussion as far as they can before they run their head into the editor's hammer. Regards, Niels." It's true that my finances were cut majorly, but I have to say this has been in many ways okay for my wife and I. We've learned to live on less. We pay less taxes, which is very nice. And we are practicing living without the grid, using our wood-burning stove and so on. Leslie and I have actually taken the opportunity to try to live without the electric grid, anticipating that it may go off at some point in the future. And we're getting ready for that eventuality. And the facts are in, and I think now it is time for us to seek international justice. So given what we see here, both as a scientist and as a citizen, concerned citizen, I think that it is prudent for us to save up necessities, water, seeds, food, tents maybe, to build up our sense of resolve and resourcefulness. I'll tell you, there is a sense in the United States with this cloud hanging over. Whether people accept what I've been reporting and publishing about 9/11 or not, there's a sense that even with the new administration, there's a sense that the United States is proceeding towards some type of new element where we won't have the freedom of speech that we once enjoyed, freedom of movement, ability to get cheap food and water and so on. World governance. Yep, New World Order, for example. I'll leave it at that, and I want to thank you for your attention. Thank you very much. Thank you. Thank you very much. Thank you very much.
You look like our Prime Minister.
I do?
But with balls.
I'm not sure that's good or not, but yes, I order an investigation of 9/11 because of the deaths of Australian citizens that day. Yes.
Is it true that the towers were designed to take aircraft hits?
Yes, that's correct.
That they were?
Yes, and that's in this first paper of mine, why indeed did the towers
But that was
blow.
multiple hits too.
They were designed, the towers, according to the engineers, it's also in the 14 points paper, as I recall, briefly, but the engineers looked at the possibility of a large aircraft. At the time it was 747.
Yeah.
Or was it 707? Thank you. 707, right. Hitting the 70s, so 707 hitting the towers, and it would not cause them to collapse. That's right.
So there's no theory on why they would collapse, given the structure was designed
not just
to take
from
that.
a plane. You know, the theory, again, in both cases, the towers and Building 7, NIST resorted to computer models, which they won't share with you. You just have to trust them.